This video covers the nomenclature of coordination complexes. Here we will work through problems that translate between name and chemical formula. Before we do that though, we'll take a quick look at the nomenclature rules because there are always nomenclature rules. Now there is a separate video that goes over metal ion nomenclature in case you're looking for some focused examples on that part of it. A metal ion is always a cation, no matter what, and its symbol with charge always looks the same. Where it changes is if that metal ion is part of a cation or a neutral complex or an anion complex. If the metal is part of a cation or a neutral complex, then it keeps its original elemental name unmodified. If the metal is part of an anion complex, then it takes on a modification of its name, which will either be the element or root plus ATE or a special name that ends in ATE. In these tables, I've listed the metals that we will see in this class. The first table shows the element or root plus 8, those metals that follow that, and the second table shows the 6 that have the special names. The other thing is that most of the time we'll be dealing with a Roman numeral. Remember that the Roman numeral in the name of the metal ion is exactly equal to the charge of that ion. The next part of the nomenclature rules involves the ligands. We will see neutral ligands and anionic ligands. There are only 4 neutral ligands that we will see in this class, and they all have special names. Be careful about the spelling because sometimes they can be a little bit tricky. The rest of the ligands that we will see are anions. In this class, we will use the IUPAC rules for nomenclature, and they may be different than the rules that you find in textbooks or other resources. The anionic ligands, you can see that it's a very simple change from the anion name to the ligand name. So for example, if we take a look at fluoride, to obtain the ligand name from the anion name, we simply change the E at the end of the anion name to an O. So instead of fluoride as the anion name, we end up with fluorido for the ligand name. All of the anionic ligands follow this format. If there is more than one ligand in a particular complex, then we need to use prefixes. Those are the regular prefixes that we have used for other nomenclature: di, tri, tetra, penta, hexa. If the ligand already has a prefix built into it, like ethylene diamine or diethylene triamine, then there are special prefixes that we use: bis for 2, tris for 3. And the last part of our rules for coordination complexes is how we put it all together. With the chemical formula, the metal goes first, and then the ligands go in alphabetical order by the letters in the symbols. So that is a little bit different than I think what seems intuitive. In the name, the ligands go first and in alphabetical order by the name, not including the prefixes. So in other words, if you have a di-aqua, it goes in alphabetical order by the A in the aqua, not the D in the di. And then the metal goes last. So our first examples will go from chemical formula to name. I recommend that whatever order you use to figure these out, that you do go carefully through the entire formula and identify everything that's there. The formulas tend to be a little bit shorter than some of the names. That advice is especially important when we go in the other direction between name and formula. But even with these formulas, I think it's important to identify the metal ion, what is its name, the ligands, is there a prefix, those types of things. The first thing that I will do is to figure out the charge on the metal ion. Remember that the sum of all the charges, the metal ion plus the ligands, has to equal the charge on the complex. So what we have here is X for the metal ion plus the charge on our ligands. The amine ligand is a 0. We have 2 of those. And those have to add up to the +1 that is the charge on the entire complex. So what we end up with is X equals +1. So that's the charge on our metal ion. So we know that we have silver +1. How we name that depends on whether this complex is cation or neutral or anion. It's a cation complex. That means that we will name the metal ion with its full unmodified element name. So the metal ion will be named silver 1. The next thing we do is we take a look at the ligands that are here. We have the amine ligand, and we have 2 of them. So amine has 2 M's in it. There are 2 of them, so that makes it diamine. The next thing we do is we piece it all together. The name of the complex will go in order of ligands first, then metal, then the word ion, because this is a standalone complex. So our final name for this is diamine silver 1. It's all one word with no spaces, except for now we have a space before we put the word ion. So it's diamine silver 1 ion. In this example, we'll take on a similar approach. First, we'll get the charge of the metal ion. Now our metal is zinc, so we might just remember that zinc will always be a +2 charge. It's never anything else. And so we could just write that down. However, I think it's a good idea to double check mathematically, like we did in the last example. So the zinc is X. We have 2 waters, so +2 times a 0, plus 2 times the charge on sulfite, which is a -2, and that has to equal the charge on the complex, which is a -2. So doing this math, we end up with X minus 4 equals -2, or X equals +2. Next, we identify the type of complex. So because that charge is a -2, we know that this complex is an anion, and that informs how our metal ion will be named. So because it's an anion, we will take on the root or element name plus ATE, and so this becomes zincate. No Roman numeral here because zinc has a fixed charge. It is never anything else but a +2. The next thing we'll look at will be our ligands. So we have water as a ligand, and there are 2 of them. And we have sulfite as a ligand, and there are 2 of them. So our water ligand is aqua, but because we have 2 of them, we're going to call it diaqua. Our sulfite, we also have 2 of them, so it's disulfito. Remember, with the anionic ligands, we simply change the E in the anion name to an O for the ligand name. We're ready to put it all together. We have to make sure that we are taking the ligands in alphabetical order by name, not including the prefix. So we have an A and we have an S. So the diaqua ligand will go first, the disulfito ligand will go second, and the metal ion always goes last. So putting this all together, the name of this compound is diaqua disulfito zincate. No Roman numeral, but we do need the word ion. Our next examples go in the opposite direction, and it is especially important here to dissect every part of the name to make sure that you don't forget something. So the metal ion we have is gold 1. So we can write down the symbol and the charge. We know what the charge is because the Roman numeral tells us. We only have one ligand here, and it's an aqua, and there are 2 of them. So the dye tells us 2, and the aqua tells us H2O. So when we go to write the formula, we'll write the ligand like this, indicating that there are 2 of them. When we write the formula, we enclose in brackets. We put the metal ion first. We do not include the charge when we write it in the complex form. Then our ligands. Now there's that alphabetical order that we have to follow, but in this case we only have one type of ligand, so we don't have to worry about it here. And we enclose the whole thing in brackets. Now the last thing we have to do is figure out what the charge is on the complex. For this, we just add up all the charges that we have. So we have a +1 for the metal ion, and we have zeros for the ligands, which means the charge on our complex is going to be a +1. So our last example looks a little bit complicated, but this is where practice comes in and why it's so important to go through every part of the name and pick out where are the ligands, where are the prefixes, where's the metal ion, all those different parts. So I'll start with the metal ion again. So the metal ion is right here. Plumbate. It ends in ATE. It's one of the special names, and I know that that corresponds to lead. So that's symbol PB. Roman numeral tells me what the charge is. Looking at the ligands, I have a dibromido, so that's 2 bromides. I have a dinitrato, which is 2 nitrates. So if I rewrite these ligands, how they'll look when I go to assemble them into the chemical formula, I'll have a Br2. Now, the Br2 is not diatomic bromine. It's not elemental bromine. It's 2 of our bromides, but when we go to write it in the formula of the complex, we write it as Br2. And then our nitrate will look like this. When we go to write the chemical formula, we have to put the ligands in alphabetical order according to the letters in their symbols or in their formulas. So we have a B and we have an N. So that means the bromide ligands will go first, the nitrate ligands will go second, and with the chemical formula, we always put the metal ion first. So we'll start to get that written down. We have PB, Br2, NO32. So that's what our chemical formula looks like, but we do need to figure out the charge. So again, we just add up all the charges that we already know are there. So we have a +2 for the metal, plus 2 times a -1 for the bromide, plus 2 times a -1 for the nitrate, gives us a total of -2. So the charge on our complex is a 2-.